Good morning, everybody, and welcome to our next session of our Digital V-Days. Today is the last day, but we still have some topics coming up, so keep tuned. This morning, I will moderate this session. My name is Markus Eberle, and I'm happy that you took also the time to participate in this session. The topic of today is, one moment. The topic of today is EMC pre-compliance measurements and optimizations. And I'm very happy also to welcome our speaker today, Muhammad Ahsan Abbasi, who is working at Würth Elektronik as an EMC laboratory engineer. So he is doing the presentation directly from Munich in our new office there, and also in the laboratory from there. So just before we start with the presentation, a few information from my side. You will be muted during this webinar. This means that you cannot ask us your questions via your microphone. I think you know that. But nevertheless, you have the opportunity to ask us all your questions with the Q&A function. The webinar will be about 30 minutes long, and then after that, we will have some time scheduled for your questions. We will go then in a Q&A answer session. And if we can't answer all your questions within this live webinar, we will answer them later on via email. You will also get the link to the presentation you will see, and as well to the recording of the session. So you will get all materials to get all the informations. So now I'm happy to hand over to Muhammad and wish you an exciting webinar. Have fun. So Muhammad, we can see your screen and also the camera, but the camera from the laboratory. Now we can see you. Perfect. You're good to go.
Yeah. Hello, good morning, everyone from EMC Lab Munich. Thank you so much for joining this session. My name is Muhammad Ahsan Abbasi. You can call me Ahsan. I'm working as EMC engineer at Würth Elektronik. I have joined Würth Elektronik in 2019 as a student and working with them as a full-time employee since 2021. Today we are going to talk about EMC topic, pre-compliance, some measurement stuff maybe, and overall one important thing, because some pre-compliance stuff and measurements are already done in some of the webinars. I have an interesting topic about legislation and directives to discuss with you. So just to start today's presentation, as Markus has introduced you, 30 minutes presentations. If you have some questions and answers, you are welcome to share and we will try to answer. The agenda for the presentation goes like, let's talk about a little bit this EMC, what it is, and then I would like to talk about a road to compliance, how products are compliant in the European market, for example, and what is the role of EMC directive, how it is applied to your product, what EMC measurements and standards are there. I will show you an example of a buck converter with a design tip about the input filter components placement. And then I would like to introduce you something about our service or EMC lab service we are offering to our customers. So let's start. First of all, what is this all about? Electromagnetic compatibility, EMC, EMI, EMS, different wordings you have heard. So the word compatibility in the EMC is more or less, we need to think of when a product which has some electrical or electronic component in it, for example, or a system, when it's in the market, in its intended operational environment, it is not alone. He has so many neighbors there. There are many communication systems working there. There are radio broadcasting systems. There will be humans who will be touching or using this device. So in that environment, we need to make sure that our device is good enough that it doesn't disturb others, as well as it is strong enough that it doesn't get disturbed by the others. So when a device has this functionality and equipment has this ability, they say that it's electromagnetically compatible. So in a nutshell, normally what I used to say is let others live and live. So this is what we want to achieve. How we will achieve this? Just go a little bit to the history and legislation side. In 2008, a new approach was defined, and as a result of this, a new legislative framework was developed. The purpose of this framework was to introduce the concept of a single European market, so that a product which is, for example, compliant in one state of EU member states, it should be freely floated through the whole market. Uh, and then this new legislative framework has made some things, how you will monitor it, what will be the role of surveillance authorities, and how the conformity assessment procedures should look like, and what are the clarifications about this special CE marking which we see on most of the products nowadays. As a result of this new legislative framework, 22 new approach directives were developed to cover the more or less whole range of the products in different areas. Some of the most relevant one from our point of view as EMC engineers, or for example, design engineers, or EMC directive, low voltage directive, radio equipment directive, and there are many more. How does this directive stuff performs? Like at the end, the purpose is to get this declaration of conformity document. It has some requirements that it should clearly mention what product it is, what clear identification of the product, which directives or norms it is complied with, and which harmonized standards have been used to get the compliance to the specific directive. And then you need a representative, normally a technical director of the company, and if you have used the notified body, it should be get signed by them. When you have this declaration of conformity document, you are good to go with putting CE marking on your product. Yeah. So now we know that, yeah, how it starts with the directives and how you go to a declaration of conformity. Let's check that what is the role of these harmonized standards. So as a result of this new legislative framework, it was decided that the standards will be harmonized, because we need a system how we will implement all this in the complete European market. We need a complete system, and there should be standards which are applicable in all the standards, not only on the national level. So the story starts from here. Every directive gives you some essential requirements, very basic safety and the relevant, for example, EMC or radio frequency requirements, which we define as essential requirements. And you need to know about those essential requirements when you are going to release a product in a market. So then manufacturer makes a risk assessment. As a result of this risk assessment, he shortlists all the relevant essential requirements which are applicable to his product. And then to meet these essential requirements, he can choose the relevant harmonized standards, which will help him to declare that this essential requirement is complied or covered by this specific harmonized standard. When you choose the path of harmonized standards, you get more or less a presumption of conformity for your product. There is also a possibility that this is some new technology or product, or harmonized standards are still doesn't exist for your product. You can also define some direct applications or other specifications which the manufacturer, for example, thinks that is okay to define the EMC assessment or the compliance with other essential requirements of the directives. But in that case, you will not get the presumption of conformity. As an example, I will focus on more or less EMC Directive 2014/30/EU. We talked about essential requirements. So I have an example. So these are the essential requirements defined by EMC directive. It talks about some general requirements and some specific requirements. In general requirements, it talks about electromagnetic interference and electromagnetic susceptibility, that your product should not interfere with other products, and as well as it should not be get disturbed or should receive interferences from other products in its working environment. So this is how we say electromagnetic compatibility. When you achieve EMI and EMS, you will achieve EMC actually. And in interference, we have two paths to get interfered with, either conducted or radiated emissions, or then if you talk about susceptibility, we can have conducted immunity or radiated immunity. So this is how the EMC is normally classified into conducted and radiated emission and immunity. In the specific requirements, they are specially for fixed installations. The directive really defines what a fixed installation is. And for fixed installations, to install them, there are some good engineering practices which the manufacturer or installer has to follow. As well, when it is installed, you also have to comply with all the general requirements as well. Yeah, so until now, we talked about EMC, we have talked about directives, we talked about a role of harmonized standards, we talked about what EMC directive gives us as a guidelines, like for example, essential requirements, and why we select the harmonized standards to comply to those essential requirements. So now we will talk about as a next step about the applicability of the EMC directive, which provisions or which requirements should I apply to my product? But before that, I need to answer either my product lies within the scope of the EMC directive. This is simple. No, sometimes not, because you have to answer some questions before deciding this. For example, with a very simple some steps you can start with, that if there is any electrical or electronic component, then your product lies within the scope of EMC directive. But if it has already been excluded from this from the product list sometimes, then you can exclude the EMC directive. And one another thing, sometimes it also happens that EMC requirements are already covered in some other directive. So in that case, the blue guide clearly tells us that the other directive which is covering the EMC aspect, for example, radio equipment directive, if it's covers the EMC aspect as well, that directive will take preference and you will exclude your product from EMC directive. And also it is defined some inherently benign equipment which have no impact on the EMC, then you can exclude it from the EMC directive. But this is sometimes not easy, because an interesting presentation I saw from BNets A, Bundesnetzagentur, where they showed the results of different products which were using ready-made connecting devices like coaxial or HDMI cables. And the shielding was very poor due to low manufacturing cost. Apparently, our RMCD device it looks no impact on EMC because it doesn't have directly any electrical component, but no, because it is directly used mostly with multimedia equipment, and it really impacts the EMC performance of the complete application of system later on. So you need to be careful here. Yeah, when you have this basic question solved and you know that this is okay, then there are some more questions which need to be answered before really deciding, because you need to then separate either your product lies within the category of an apparatus or a fixed installation. For fixed installation, it is normally relatively clear, because fixed installation is defined if your system or application has a permanent predefined location, then it will be a fixed installation, and you will use the provisions of a fixed installation in that case, which are defined in the directive. But if it's a component or a subassembly, or it's a finished appliance or a combination of different appliances, then you always need to consider the fact that either this component or a product or a finished appliance is used or intended for an end user. is end user able to touch it? And from end user, you mean a consumer, not a technical person. If, for example, we can take an example of a of a PC where graphic or compute or a video gaming card, which are available on the market as separate product, and a consumer can change it by itself. So they are separately, EMC directive is applicable on these both products. But for example, a component or IC or a capacitor or an inductor, which is really soldered by a technical person, it's not intended for the end user, then EMC directive is not directly applicable on these components or sub-assemblies, yeah? And these will then lie in the category of apparatus. And when you know that it's an apparatus or a fixed installation, then you can use the provisions from the EMC directives which are applicable on apparatus. There is a defined process for that. And for fixed installations, it's the provisions of the fixed installations. And in case of apparatus, there is you need to consider, and this is a little bit more complex, but worth to discuss that either the sub-assembly, for example, or apparatus is part of an installation, and then the EMC directive will be applicable to the whole system, for example, but you are not intending to make it available in the market as a single separate unit, or it is not commercially available, then it's the choice of the manufacturer that either he wants to choose the provisions of applicable for an apparatus or for an equipment which is intended to be applied in or sold as a separate unit commercially. Yeah, so we when we have decided, for example, or we have a clear view after a risk assessment and EMC assessment that my product lies, for example, within the scope of EMC directive, then now how the conformity assessment procedure is done. Normally, the preferred way is to check that which harmonized standards are applicable, and you make measurements. So here comes the compliance and pre-compliance measurement topic with these harmonized standards, and you keep your test reports, which is part of your technical documentation then, or sometimes it is also possible that all harmonized standards are not available and your product has, there are partly some harmonized standards, or in some cases there is not at all any harmonized standard which is applicable. But in those cases where you are not for example, applying a harmonized standard, you should have detailed documentation of the solutions which you have applied, which describe the compliance with the essential requirements, and you have to document them in your technical documentation. Once all your documentation is ready, then again, there is a choice of getting the type certification from a notified body, or you can also follow Annex 2, which is given in the guidelines of the directive to without a notified body. You can declare your conformity and you can prepare your document, and then you can put CE marking on your product. Yeah, so EMC pre-compliance measurements. Now we have a very good idea why we do EMC measurements, how we move from the concept to final compliance measurements. And here we will talk about where the pre-compliance measurements lies. Yeah. So, design process of a product and EMC process should be hand by hand from the very start if you want to save cost, money, and headache later on. After the concept and design, where you consider EMC initially in the initial stage of the design from directive and legislation point of view as well, and your design reviews include the EMC point. Then when you have your first prototype, you want to perform some pre-compliance measurement in a pre-compliance lab to save cost and have an initial idea that where your product lies with respect to the standards and stuff. And then you move towards a fully compliant lab in a pre-production stage before going for the series production. So this is the area in your prototype during your development stage. We want to support you with the pre-compliance measurement, not only measurement with troubleshooting and optimizations as well. And we have 2 labs in Waldenberg and Munich for this purpose. So one of the most important thing in the pre-compliance measurements or the measurements is you should know about the standards. So let us talk briefly about standards. So the standards are reclassified into basic standards, generic standards, and product or product family standards. Yeah, basic standards are more or less the basic guidelines how to perform EMC assessment. They don't give you the exact limit lines or stuff, or they have not specific performance criteria, but they talk more about um, overall the equipment, the test setup, how should it look like, what requirement should it meet. For example, CISPR 16 is a basic standard, and then subclauses of CISPR 16 defines requirements for the equipment which you use, or how should the overall, for example, the test setup, a shielded room, conducted emission setup, or a radiated emission setup in a fully anechoic chamber should look like, or what requirement it should meet. Then we have generic standards. Generic standards normally talk more about the environment, in which environment your product is going to be used, and then it defines, for example, some limits and some test procedures for equipments which are intended in an industrial environment, or in a house, in a residential or commercial light industrial environment, commercial environment. But when they have to do about the equipment and setup, they always refer to the basic standards, which we can clearly see in different tables given in generic standards. Then we have product or product family standard, which are very specific to us, to a defined product family. For example, CISPR 32 for the emissions of multimedia equipment, or 35 for immunity of multimedia equipment. So here we have very specific EMC requirements, specific conditions applicable to this group of products or system. But again, for the measurement setup and equipment, it also refers to basic to the setups of the basic EMC standards. Yeah. So we have talked a lot about how the background of the EMC, and why, or how we make our journey towards the compliance, and how we pass through the pre-compliance. I will now show you something interesting on a design level. So this is a buck converter design. I have used a Magic Power Module IC from our Magic team. This is a 3 ampere module with input specifications of 6 to 24 volts in and 5 to 24 volts out. And I will focus on this differential input filter component. So this is, you will see some very interesting results, because yeah, and now the use of the integrated ICs or solutions is becoming more and more in the market. And they need normally an input filter, so that in the final application of system, you don't get something from your converters. But the placement of the input filter components with respect to the input capacitors is interesting, especially in the conducted emission setup. In the first measurement, you can see that I have shown it with a diagram as well, simply that we know we have our DC-DC converter here. We have our input capacitors. These are MLCCs. We have then we have our filter components, for example, and a filter inductor. This is an LC filter, and ceramic capacitors as MLCC for filtering. When these filter components, the capacitor, inductor, and the input capacitors of the converter are too close, and right now the inductor is also the unshielded one, you see that we have at the switching frequency the highest peak at about 46 dB, and then in this area the peaks are relatively higher. They are above 30 dB. Here, my focus is not the standard or the limit lines, but I want to show you the impact of the placement of the input filter components on the conducted emissions. So in the next measurement, let's see, I have just moved them on my PCB, the filter caps a little bit away from the filter inductor. The inductor is still an unshielded one, but I have just increased the distance between inductor and the caps. And you can see here that I have reduced my peak at switching frequency from 46 to 37 dB. And here in this region as well, where some harmonics or some resonances can also be, but from 1 to 10 megahertz range, the peaks are all below 30 dB. So just moving a little bit away, we have reduced some couplings here, couplings between the filter components, or maybe couplings between the filter components and the IC, integrated IC, DC-DC converter IC we have here. In the next measurement, for example, I have once again moved the components closer to the filter inductor, but I have now used a shielded inductor here. So you can see we are not like the first measurement too high, but we have reduced the peak to 38 dB. But here in this region, because the components are again close, some couplings and resonances are happening here, and we are again having some high peaks in the region of 1 to 10 megahertz. Yeah, so with the shielded inductor, for sure we have a good attenuation of the filter, but we need to consider this area sometimes as well, because yeah, in the final systems of application or applications, sometimes these things combine and we can have issues. In this measurement, I have applied both the solutions. For example, I have moved the caps away, and I have used here a shielded inductor, and then you can see the results. Very nice. We have really reduced the peak even to just 32 dB. Very nice filter performance. No conducted EMI problems at all. Very far away from all the limits. And also in this region as well, we have very nice EMC result now, because the inductor is shielded, as well as we have enough distance between the input caps and filter components from the inductor. In all these measurements, the position of the DC-DC converter IC is fixed, yeah? So because I am focusing only on the placement of input filter components. Here, as a summary, this is a good design tip, because DC-DC converter, sometimes there can be more than one integrated solutions in a complete PCB, in a system, or in an application. So when we are putting our filter components and caps very close to each other, we see that we have a bad result. If we want to improve it, because this is always better to be very far away from the limits on very component level, so that in the system you have very good performance. Also, it is very nice for your customers who are using your product, for example. But it can also happen that you have space constraints and you cannot just make it far away from the inductor in horizontal direction. So there is also a possibility. I have tried some measurements just to move your inductor a little bit down or up, so that it's not in the direct in the line of your converter and your filter caps. This also improves your results, yeah. And but if you have no space constraints, of you have enough space, if you can move your caps stuffs away from inductor, you can do it as well. And it is then the question of the cost, if you want to use a shielded or unshielded one. But we can clearly see that the magnetic couplings around the components of unshielded is much higher than the shielded inductor. Yeah. So yeah, then at the end, I would like to talk a little bit about our new EMC lab in High Tech Innovation Center Munich, and our EMC lab service. We want to offer our customers in their development stage pre-compliance measurements. We want to troubleshoot and optimize their products in our labs as well. They can book our labs. We have a nice shielded room with the capability of performing conducted emissions and immunity testings for the defined range from international standards CISPR 16-2-3 or the generic standard 61000-4-6 for conducted immunity. We have a nice burst generator here as well, where we can perform surge and burst tests with 4-4 and 4-5 up to 5 kilovolt or 5.5 for burst. We can also perform ESD tests with up to 16.5 kilovolts for air discharge according to 61000-4-2. We have a very nice, I can show you in my camera as well, a fully anechoic chamber. You should see it now. This is 3-meter fully anechoic chamber fully compliant, but we are not giving certifications or accreditations. This is not an accredited lab. We are focusing on pre-compliance measurement to support our customers in the development stage. We can perform radiated emissions and immunity measurements. The chamber itself is immune up to the frequencies of 43 gigahertz, but by changing the antenna to horn, I can perform radiated emission measurements up to 26 gigahertz and immunity measurements from 80 mega to 6 gigahertz up with the field strength of up to 20 volts per meter. So if you want to have some measurements or if you have any EMC or really questions related to EMC or standards or norms or directives overall, you can always contact us with our official EMC lab address, emc.lab@v-online.de. And one of our EMC engineer from Waldenburg or Munich will reply to you, and we can proceed if you need measurements or you need some consultation on standards as well, for example. So that's all from my side, more or less. Thank you so much for joining the presentation. And now we are open to the questions. If you have any question, please feel free to ask.
Okay. Ahsan, thank you very much for your presentation. And yeah, really nice to see what chambers and laboratories you have there in Munich in the new high-tech innovation center. So now it's time for your questions, and I see in the meantime we've got already a lot of questions. So yeah, let's just start in. Just mentioned if we can't answer your question now in the live webinar, we will answer them later on via email. And if you also have any questions left, you see the screen at the moment, just email us and you will get your answer. So then, Ahsan, let's start with the first question. After applying a relevant harmonized standard, how can I verify that the defined essential requirement has also been complied?
Okay, interesting. So, as we talked in one of our slides that the preferred way is to use the harmonized standards. And after your risk assessment, when you have shortlisted your essential requirements, which you have to be comply to put your product in the EU market, then you select which harmonized standards you will use to comply to those essential requirements. And when you go to the harmonized standards, for example, you will see that in the annex of the harmonized standards, Annex ZZ, it always refers to the EMC directives, which essential requirements defined in the specific directive is complied through this harmonized standard. So you can always verify this in the annex of the standard. If I can quickly show you, for example, just a moment. Maybe if it opens quickly. So if you can see my screen,
yeah, we can see your screen.
This is CISPR 35, for example, and you can see the unhang ZZ or Annex ZZ in English. It tells you which directive or it gives you the reference to the directive which is applicable to through this harmonized standard. Because EN 55035 is the immunity for multimedia equipment, and this is now harmonized. Yeah.
Okay. Ahsan, thank you very much for the answer. Then let's just go on. Next question here. How to book a chamber for EMC lab service? Is there a possibility?
Yeah. As I told you in one of my last slide, but normally for customers, the process is that you can, if you want to measure something in your chamber, if you have product, or if you want to test some of your prototype, you can always contact with your Ansprech partner or contact person from Würth Electronic. You can talk to your respective ADM, and he can directly write to us. Or there is also a possibility, you are always welcome to directly write to us on our official email address emc.lab@v-online.de, and we will get back to you and we'll discuss with you what product is this, which standards make sense, and what capabilities we have is set up makes sense for us and you, and then we can book the appointment and you can travel to us for the measurement. You can find the EMV lab page on our official website as well, and you can download the EMC lab flyer, which nicely describes the capabilities of the measurement setups of our Waldenburg and Munich lab as well.
Perfect. Thank you. Yeah, then let's just go on. The next question is regarding slide 19. Maybe you can open it in the meantime when I'm reading the question. So moving capacitors C11 and C12 and C in 1 and C in 2 away from the inductor L1. How much is a little bit away? 1 millimeter or 0.5 millimeters?
Yeah, this is the millimeters is already, I will say, a big range. You can, this is more or less hit and trial. This I have used the design more or less. We show for all evil boards more or less, but in a real application, this is an interesting question because you have in a real application more flexibility to put your components around DC-DC converter. You don't always follow a horizontal, more or less, style of putting just in line with the converter, but you have a bigger PCB and you have more flexibility to move your components around it. So it's more or less normally a hit and trial, but around 1 mm is or less than 1 mm is always okay when you are not too close. I will exactly right what I have used from my Altium design, which is on my personal PC, and I can send you by email exactly what distance I have used, but it is more or less normally a hit and trial. It's not like too big, not in really more than millimeters, but an adequate distance which can stop the couplings is normally enough.
Okay, Ahsan, thank you very much for your answer. So we still have some time left, so we take the time to answer all your questions because, yeah, I see there are a lot of questions coming in. That's nice to see all the feedback. Next question, as a rule of thumbs, how far should I place my filter inductor away from input from the filter cap or, yeah, input filter cap? 3 to 5 millimeters, is it sufficient to see an effect? Can you say something to that?
Marcus, can you please repeat? There was a little disruption in your voice. Sorry.
Oh, okay. Yeah, I will repeat it. So as a rule of thumbs, how far should I place my filter inductor away from input filter cap? So 3 to 5 millimeter, and is 3 to 5 millimeters sufficient to see an effect?
3 to 5 is already a bigger distance. I will I will say that there is no rule of thumb from my side. It depends on the IC as well. Yeah, it depends which integrated solution you are using. Some are really nice. For example, if in the integrated solution, there is also a buck converter, and this integrated buck converters have already an inductor integrated within the IC. If they are using a shielded or unshielded inductor, this also decreases or increases the range of couplings which this IC can make with the surrounding magnetic or capacitive components, for example. So you should not really, I will say that, define a rule of thumb, but with just one or one or two pre-compliance measurements, you can easily think of that which distance makes sense. So always start with a minimum, because we always need to consider the space on a PCB, which is always a relevant topic for the customer. So yeah, we should start with the minimum distance which we can move the components away, for example 1 millimeter, and then we see if we really need to increase the distance depending upon what kind of integrated IC on the DC-DC converter level we are using, and what quality of the products, for example inductor and capacitor, we are using. This also depends on overall PCB design, for example number of layers, your grounding planes and stuff. So it's not really straightforward to say a single rule of thumb for every design. Yeah, you need to think about it or look at it with the help of, for example, measurements.
Okay, thank you very much for the answer. So yeah, we also got another question which goes into the direction of this. So I think, yeah, you already answered it. Of course, if there are questions open, then just also email us afterwards or just resend the question. So then next question is about the slide on page 20. And the question says, what separate distance you have used in your example? So yeah, just like on slide 19. Was it the same?
Oh, what exactly he's asking? Can you repeat, please?
Yeah, so regarding the slide on page 20, what separate
20,
distance you have used in your example?
Okay, so this is more or less the same question then. So yeah, I will exactly email the exact distance which we separated between the components. But the idea here is to show, I think I have this. This should not be more than 1 to 2 millimeter. I have this PCB on my desk right now as well, but I will exact so that if you want to know from the Altium design, the exact distance as well.
Okay, Ahsan, thank you very much.
Yeah, I can already see a lot of questions flowing on different topics. I think we will run short of time, but to all the participants, we will get back to you via email and answer all your questions as well. So, but I think we still have time and we can move to next question as well. 2 minutes.
Yeah, exactly. Thank you. Yeah, so the answering will do Ahsan. So thank you for that. Then next question. Do you also offer testing of the IEC 60601 to 26?
IEC is, if it's not medical standard 60, 61, but I need to check which standard this exactly is. For example, with the 3-meter chamber and with the CISPR requirements of the setups, you can more or less cover whole commercial or industrial EMC range. We are not doing automotive, but the other standards should be possible until unless they have not very specific test setup requirements or some specific equipment required, which is not covered in, for example, industrial or commercial EMC. So for this specific standard, I will check what are the setup requirements and we'll get back to you. No issue.
Okay, so then last
But normally,
question,
if generic standard is
about
applicable,
the
then it's okay.
automotive standard. Are you supporting also EMC lab service as per automotive standard CI SPR 25?
In the Munich lab, you know, for CISPR 25, you need more or less a special setup. Just a moment, I can show you my chamber, and you can see it now. From CISPR 25 setup point of view, your device should have a reference ground plane on your turntable, on your test table, for example, and this reference ground plane with low inductive connections connects to the walls of the chamber, but this is not possible in our chamber. we are not doing mostly the automotive, but industrial or commercial EMC, for example. In the Waldenburg lab, it is possible to do some automotive tests because you also need a monopole antenna and a reduced distance to the device because higher field strengths are required in case of automotive measurements. So if you have some special requirements, we can always discuss if it is possible to do in Waldenburg then, because we have a monopole antenna in Waldenburg and we can connect to the reference ground plane through the walls of the chamber.
Okay, yeah, and also I'm here located in Waldenburg. Also, the area is really nice, so it's worth a trip. So thank you very much, all you attendees, for your attention, for the interesting questions, and yeah, for your attention. And also big thank you to Ahsan for your presentation and all your answers. I hope you stay tuned with our Digital V Days, and I wish you a good day. Thank you and goodbye.
Thank you so much. Goodbye.